I'm going to do a quick video on the Unit 6 review. I went ahead and crossed out number 2. It's a little bit beyond what I'm going to ask of you to do on the test. So start off with the area problems. We're just trying to find the area bounded by the two curves. Step 1, you want to graph both of these functions. I already did so in Desmos. So I see this. I'm just trying to find that region. All I care about is that you graph that region. So they cross at 0, 0. They also cross at 2, 4. So I'm going to go ahead and graph those 0, 0, and 2, 4. I've got one parabola going this way, and the other parabola is going to come this way. And all I care about is that region right there. Okay. Obviously, I'd want you to graph these in a little bit more detail than what I just did, but we just are trying to find that the area of that region. What you need to do is determine if your rectangles inside this region can stand up or lay down. I always try to see if they can stand up first. So what I mean by that is your rectangles can stand up as long as you have one function defining the top of each one of those rectangles and the other function determining the bottom of those rectangles. And as long as that's the case, they can stand up. So these rectangles are allowed to stand up. These could actually lay down as well, but I'm going to have them standing up. If they stand up, that means that I'm stacking them horizontally. So my integral is going to be the horizontal bounds, which would be 0 to 2. Also, if they stand up and I'm stacking them horizontally, these are x values. So since those are x values, that means I want these equations in here to be variables of x. So all I need to do when I do area is top minus bottom. So my top function is this 4x minus x squared. And then we subtract away the bottom function, which would just be x squared. We do all of that dx. So the area ones I am going to have you work out by hand. I'll just get you started on that. I'm probably not going to solve this whole thing, but the first thing I would do is combine like terms. These parentheses aren't really necessary. If your second function is more than one term, you just want to make sure you distribute that negative. It's not a big deal here. So in this problem, I'm just going to have 4x minus 2x squared whenever I combine those. And then remember to solve an integral, we do the antiderivative, which would be add 1 to the exponent, divide by the new exponent. So that first term will be 2x squared, and then we will add 1 to the exponent here, and divide by that new exponent, so 2/3 x to the cube, and then we evaluate from 0 to 2, which means we are going to plug in 2 to that, and then subtract what we get when we plug in 0 to that. And that'll be the answer. I'll let you work that out. Number 3, if we graph both of those functions, I have those graphed as well. Let me take these away. I'm going to add these in. We get this region here. Notice how in this region, I can't have my rectangles standing up. They can't stand up because a rectangle over here would be defined on the top and the bottom by this purple parabola. That can't happen. I realize that rectangles over here would be just fine. The green would be on top, the purple would be on bottom. But if any one rectangle is hitting the same graph on top and bottom, that's not okay. So we want to try to lay them down. If we lay them down, we do have the green function would always be on the right, and the purple function would always be on the left. And so that's what I want. Now, if I lay the rectangles down, then that means I'm stacking them vertically, right? So they're going to be stacked in there vertically from -4 to 0, because they're going to be laying down, stacking them up. Those are y values. So that means that my equations need to be written in y. So we're going to go from -4 to 0. I'm just going to go back to the graph here so we can see this. We're going to go from -4 to 0. These rectangles are laying down, right? So we're stacking them up vertically from -4 to 0. And then that means that we have things in y, right? So we're going to go back to here. I just need to rewrite this, so I need to solve this for x, is essentially what that means. So if I solve that for x, I'm going to get x equals -y. That's going to be my right function in this case, right? The green one is the right function. So I'm going to do right minus left. So we're going to go with -y minus the left function, which would be y squared plus 3y. And then we're going to do dy. We would distribute this negative, combine like terms, do the antiderivative, and so forth. Okay, so that's how you do area. To do volume, step one's the same. You're going to graph the regions. So I've got this 2x and x squared graphed here. It's this region here. And then it's going to tell you that we want to rotate this around a specific axis, right? The first thing that I would do is I would figure out the rectangles. Can they stand up? Can they lay down? If you have the option, you could create either shape, the shell or the disc/washer. These rectangles can stand up because this lighter red would be on top and the darker red would be on the bottom. They could also lay down because the darker red would be on the right and the lighter red would be on the left. So I do have the option here to make my rectangles go either way. So we're going to rotate this about the x-axis. So what I would want to do is after I graph this, I would say, all right, well, let me mirror this region over the x-axis. So I'm going to do my best to do that here on Desmos, so I don't have to recreate the drawing, but we're going to mirror this over the x-axis, and then I want to think about one of those rectangles, right? So if I just have one of those rectangles, if I stand it up and I mirror that rectangle over here, if your axis of rotation, which is the x-axis here, and your rectangles are perpendicular, then that creates the washer or the disc shape. Think about that vertical line going over that horizontal line. That's going to create a washer shape, which would look something like that, okay? Which is totally fine. I can do it that way. So if we do washers here, the formula for a washer is we do the pi r squared of the outside circle minus the pi r squared for the inside circle. So all I have to do is determine which function determines the outside radius and which function determines the inside radius. And it's essentially further away and closer to the axis of rotation. Okay, so I'm going to go back here and we're going to go, it's pi r squared, right? So we're going to bring the pi out front. We're going to do the integral. I'm going to go back to my graph here. If my rectangles are standing up like we had there, then that means that we're stacking them horizontally. So we're going to stack them from 0 to 2 here, right? So in this case, with the washer, we're going to go 0 to 2. The outside radius was the function on top. The function on top was 2x. So that means we're going to do the outside radius squared minus the inside radius, which was x squared, and then we just do all of that dx. At that point in time, you could plug that into the calculator. Remember, don't plug in pi, plug in all of this into the calculator. That will give you the answer, and then multiply by pi. I'm going to show you that same exact region doing a shell, because we could do a shell there if we wanted to, and it wouldn't be that hard to do. Okay, so how do we create the shell shape? Well, again, we're rotating over the x-axis. That's not changing. So if I recreate that, mirror that over the x-axis again, this time I want to think about one of my rectangles laying down, because we said we could lay them down. If I lay it down and I rotate that around the x-axis, then that's going to give us this cylinder shape, which is not the same shape as the washer. Okay, so for the cylinder, it's 2 pi RH. 2 pi RH. So I got to figure out the radius and the height of this. Well, if my rectangles are laying down, then when I write my integral, those bounds have to be the y values. So in my original region, that would be 0 to 4. I'm going to have the 2 pi out front. And then the radius, unless you rotate around a line that is not the x or y axis, the radius is simply going to always be the y value or the x value to where the rectangle is. So our radius is simply going to be y or x, depending on if it's the rectangles are laying down, it's y. If the rectangles are standing up, it's x. Okay, that's not going to change unless you're rotating around a different line. Okay, and then the height is essentially going to be the same way we did the area. It's going to be right minus left or top minus bottom. So in this case, it's right minus left because my rectangle is laying down. So we're going to go the right function which is this, but I would have to change that and make that x equals the square root of y. And then I would also have to change this into x equals y divided by 2. So my height would be the right function, which would be the square root of y, minus the left function, which would be y over 2, and then dy. And that should give us the exact same region as what we just did using a disc or a washer. So we have a couple of different options there to do that one. We don't always have the options. Okay, so let me go to this problem here. This next problem, notice how your rectangles couldn't stand up. If I tried standing them up, I would have the red graph here determining the top and the bottom of a rectangle. So that doesn't work. They have to lay down. So because they have to lay down, I'm limited on what my options are. We're rotating around the y-axis, so again, what I would do is I would mirror this about the y-axis. Okay, so we'll have an intersection point up here, and then we will have an intersection point down here as well. But essentially we've got this line going here, and then we've got this parabola going through like this. But anyway, if we have one of these rectangles laying down, and we rotate that around, notice we're getting that washer shape there. Right? We're not getting a shell here, we're getting a washer. It's a circle with a hole in the middle of it. Okay? So I have to use the washer method on this one. I don't have an option. All right? So we'll figure out what that's going to look like. The washer, again, if those rectangles are laying down, we're stacking them vertically. So we're going from -1 up to 2. So we know that our integral is going to be -1 to 2. We're doing the washer method. So it's going to be pi r squared minus pi r squared. So we're going to bring the pi out front. The outside radius. The outside radius is going to be this blue line. Well, the blue line is y equals x minus 3. But because my rectangles are laying down, again, I've got to change that to x equals y plus 3. Okay, so I'm going to change this equation here to x equals y plus 3. That's going to be our outside radius. So y plus 3 squared minus the inside radius is going to be this 1 plus y squared. So that's 1 plus y squared. I've got outside radius minus inside radius dy, and that would be the integral. I don't have another option there. I cannot make the shell for that one because my rectangles had to lay down. So my rectangles were laying down. The axis of rotation was vertical. Those are perpendicular, so I'm going to get a washer or a disc. I'm not going to get a shell there. Okay. Again, I don't have the option for that one. All right. I'm going to go ahead and move past. If you have questions on number 6 or anything after that, come see me. It's a rotate around a different line. The answers to this are posted, so check that out. But if you have questions about that, just for the sake of time, I'm going to move on. I'm going to go down to average value and just talk about average value really quickly. I'm not going to ask this question about the second part of that. So all I want you to do is find the average value. And remember, to find the average value, you simply do the integral over the interval of the function, and then all you have to do is out front you do 1 over the length of the interval, essentially. So 1 over 4 minus 0, and then I am going to have you work this out by hand, so it should be pretty easy. That 1 over 4 minus 0 is just 1/4. I'm going to change this to where it's x to the 1/2 power, and then I would take the antiderivative by adding 1 to that, which means it's going to be 3/2, multiplied by the reciprocal of that new exponent, which would be 2/3. That 1/4 is also still there, multiplied by that, and we're going to evaluate that from 0 to 4. So that's going to be 2/12, or I guess I could do 1/6 here when I multiply that together. 1/6 of 4 to the 3/2 power minus 1/6 of 0 to the 3/2 power. This is just going to be 0. I don't need to worry about that. This is going to be, let's see, the square root of 4 is 2. 2 cubed is 8. So we're going to get 1/6 times 8, which would be 8/6. I believe is the correct answer, which would be 4/3. I may have done that incorrectly as I went through that really quickly, but I think my work is accurate. So that is how you find the average value. That's all I'm going to ask of you to do on that. So don't worry about, like, this question at the bottom requires you substitution. Don't worry about that. You might want to try number 11. It's also an average value question. But those are the kind of the three concepts: average value, volume, which is the big concept, which is, are we doing shells, are we doing washers? A lot goes into that, okay? And then we've got the area between two curves.